So inverses of circular functions, this requires that you have watched the intro to inverses video just so that you know how to find an inverse function and the fact that we need to make sure our original function is a one-to-one function before we start. So we're going to go through sine, cosine and tan. Now the graphs that I do won't be as exact as they could be, so just watch them so you know where they come from, and at the end of the video I'll actually put up each of the graphs sort of nicely done so you can copy those into your book. But I would copy down the algebra as we're going. So the first thing we're going to do is look for the inverse of the function, which is sine of x. Okay, so I'm just going to write that as y equals sine of x. Now remember that for inverses we need to do three things. We need to swap x and y. We need to then solve the function that we have for y. And we also need to swap the domain and the range of our function. The reason for that is when you swap x and y, you're swapping the x and y in the domain and range as well, so they actually swap over. So let's look at this one. Okay, so first thing we're going to do, swap x and y. So where there was an x, there is a y, and where there was a y, there is now an x. And then we're going to actually solve now for y. So what we're going to find, take the sine over to this side, and that's going to become y equals inverse sine of x. Okay, so this is our inverse function. So our inverse, and I'll put the little negative one there to show it's our inverse, is the inverse sine of x, from starting with sine of x. So to graph this, what we need to do is make sure that our original function sine is a one-to-one function. Now normally sine looks like this, okay, which is not one-to-one. What we need to do is restrict ourselves to one part of the function, and what we're actually going to do is restrict ourselves to this part here that happens across the origin. Okay, so we're just going to sketch ourselves sine of x. We know that at 0, sine of x is 0. At pi on 2, sine of x is 1. Okay, so there's 1, negative 1. There are maximums and minimums. Pi on 2 is like about there, sort of 1.5. So we're going to have a point there and a point there. So this is pi on 2 and this is negative pi on 2. Now we just have to sketch our graph in. So we know that sine x has that kind of shape, so it's just going to go kind of down there and around like that. So this is our function sine x. And we're going to look at our inverse function as well, but first thing that I want to do is just think about the domain and range that I now have for our original function. So the domain that I have here goes from negative pi on 2 to pi on 2. And the range that I have is just the standard one, goes from the minimum to the maximum. So what that means for my inverse function, remember that my inverse function is inverse sine of x. Swap your domain and range around. So my new domain is going to be from negative 1 to 1, because it's swapped. And my new range is going to be from negative pi on 2 to pi on 2. Okay, so we'll do this one in a different colour. Remember that if you're graphing two graphs, its original and its inverse on the same axes, that you're going to find that they're a reflection. So I'm just putting over the line y equals x. Okay, so we'll do our inverse function. Let's do the inverse function in red. Okay, so this is going to be my inverse. So we go from negative 1 to 1, so that's going to be there to there. And then to pi on 2 and negative pi on 2. So we're going to be flipping over this line. So remember to flip, it's going to end up being a point there. And flipping here, we're going to end up with a point here. And it basically has the opposite shape that you had before. So this time it's going to sort of curve down and then come back around. The only point of intersection is that middle point. So the basic shape of this graph, just roughly, is a graph that looks like this. Okay, so that's inverse sine, and down here I've just put to make sure that you restrict your domain, your range accordingly. Okay, so inverse sine. If we look at our next one, inverse cosine, again we're going to start with, so this is for inverse cos. I should really put a title here. This is inverse sine. So we're going to look at our function, which we let equal cos of x. Let that be y equals cos x. Okay, and then we're going to find our inverse. So for our inverse, what we're going to do is just swap x and y around. So we're going to have x equals cos y, and that means that y equals, take the cos over, so inverse cosine of x. Okay, again, before we work on the domain and range here, let's have a look at our graph for cosine. Now you know the cosine graph looks like this. Yep. Starts up at 1 and gets to 0 at pi on 2. Now we're actually going to work with this part of the graph here, okay, because we can't work across the origin, it's doubled up. It's not 1 to 1. So we're going to just keep this side. So what we're going to do, start off putting our original function, so it starts at 1 when it gets to pi on 2, which is about there, and 3.14, sort of about there. Let's make that a bit longer. That's pi, and this is going to be pi on 2. Okay, so let's look at our original function, cosine. So we know that it has this kind of shape, goes down to -1 as well. So like that, goes through those points. Remember that the other side would go like that, so it would continue. So this is our function f of x equals cos of x. Okay, for our inverse, we need to think about what we've actually found here. So our inverse function, we know, was inverse cosine of x. Now for our function here, which is f of x, let's talk about domain and range. So the domain and range you can see. So for f of x equals cosine of x, our domain is x between 0 and pi, and our range is y, and it's between -1 and 1. It's just like sine. So our new domain and range for our inverse is going to be, our domain is going to be what the range was previously for the original function. So between -1 to 1, and the range is going to be between 0 and pi. So we'll do this one in red. So for our inverse function, remember that wherever the intersection is here for the original function, it will be flipped over here. Okay, the reason for that is, remember that we reflect an inverse function over that line y equals x. Okay, so for our inverse, we're now going to be intersecting here at 1, and where we previously intersected at pi on 2, that's going to be up here. That's pi on 2, that's 1. Okay, we're going to also find that we end at pi, so 1, 2, 3, about there, and at -1. The reason for that is, this point previously here was pi -1. This point is now going to be up here, and it's going to be -1 pi. So everything reverses. Okay, this point here, which was 0, 1, is now 1, 0. And the shape reflected over is going to have this kind of shape. So going up like that. Okay, and that's our function for our inverse cosine of x. So in between -1 and 1, and just roughly it has this kind of shape, like that. Okay, the next one that we need to look at to finish off is inverse tan. Now for inverse tan, same thing. So we've got y equals tan of x. That's our original function, f of x. For the inverse, what we're going to do is have a look at swapping x and y again. And so we end up, take the tan over, we have y equals inverse tan of x. Now we know that for tan, what that looks like is a graph that is sort of a little cyclical, but has a repeating section that goes like that. Okay, so the part that we're actually going to choose to keep for what we're looking at here is this middle section. Okay, so I already know where these two endpoints are going to be. Remember that tan is undefined at any pi on 2 or at -pi on 2. So we're going to make that our domain and our range. So for our original function, so for f of x up here, and I'll just do this here. So f of x equals tan of x. We're going to have our domain is any x that's between -pi on 2 and pi on 2. Remember, you can't include those because they're asymptotes. The range for this is all real values. So in between negative infinity up to infinity, or all real values for y, because it goes up to infinity and down to infinity. So what that means for our inverse function, which is inverse tan of x, is that our domain this time is going to be all real x's, and our range is going to be restricted. And this is a really interesting looking graph. It's like something you probably haven't seen before. So let's put in our tan first. We'll do tan in light blue. So pi on 2 is about there and there. And we know that tan x also intersects or goes through at the origin. Okay, so that's what tan x looks like, our original function. Okay, let's graph our inverse now using the red. Now remember that with the inverse, imagine that this is reflected over that line y equals x. So now instead of the asymptotes being vertical asymptotes, they're going to be reflected over this line, which means they now become horizontal asymptotes. So rather than being at pi on 2 and negative pi on 2 in this direction, they're now going to be at pi on 2 and negative pi on 2 in the horizontal direction. So you've actually got two asymptotes, and this shape is flipped. So instead of going up, it's going to go across like that, and again, instead of going down, it's going to go across towards the asymptote. So the basic shape of this graph is this kind of shape with your asymptotes going across. So it's a very different sort of graph than you've seen before, and that's the graph for your inverse function, which is inverse tan of x. With the restricted domain, you can see now that the domain goes from negative infinity to infinity for the inverse, but it's restricted as a range now between negative pi on 2 and pi on 2. So that's the way that we get our inverse trig functions. Just here, which you can pause. This is in your textbook as well, so you can get these graphs out of your textbook. A great idea for you to have the really nice versions of these graphs in your notes, just so you can refer to them. And I've also put here as well a piece from your formula sheet for your exam. You are given for the inverses the domain and range, so you can use those when you're working through simplifying trig and also graphing. So inverse trig, all three of the functions, the graphs and the algebra to get them.